Alright, so now we're going to talk about arc length and area of a sector. Well, what are those two things? Well, arc length is just going to be the length of an arc made by this angle, right? So just this outside arc, that's my arc length. And then the area of a sector, well, a sector is just the area of this shaded in portion, right? So we've got our angle measure, and then everything inside, that's just the area of our sector. So not the whole circle, but just the area enclosed by our angle, right? Key things to consider here is that when we use these formulas, we've got some nice formulas for arc length and area. For arc length, it says arc length is equal to the radius times the degree measure. Well, okay. The radius is just, so r equals the radius. But this degree measure has to be in radians. So our theta must be in radians. And then our formula for area is somewhat similar. Just going to be 1/2 the radius squared times theta, which is just the degree measure in radians. So what would that look like in application? Well, let's give it a go. We've got a question down here. Okay, so it says a softball field forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. The outfield fence would just be this here, the arc length, and then the area of the field would be, well, just the area of the entire field. I'm going to write down our formulas first. So for arc length, we'll call it S is equal to the radius times the degrees in radian, and then our area was just equal to 1/2 times the radius squared times our degrees in radian. Alright, so we've got a picture of a baseball diamond. Now we might know from prior knowledge that a baseball diamond, this is a right angle, this is 90 degrees. Hopefully we know what 90 degrees is equivalent to in radian, because remember, this, in order for these formulas to work, we have to have a measure in radian. If we don't, well, we know, hopefully we know the conversion that 180 degrees is equal to pi radian. So what we can do is we could just do we know this is 90 degrees, we could do some dimensional analysis here, and we could, if we're looking for radian, say 90 degrees times, we'll use this equivalency. I'm going to put degrees on bottom because I want them to cancel out. And that's just going to give us 90 over 180 pi, right? So that's just equivalent to 1/2 pi, which is just equal to pi over 2. So that's our degree measure in radians. So now that we have that, we can use these formulas. Our radius, in this case, is going to be 200 feet. So I'm going to solve first for the length of that outfield fence. Length of fence is going to be equal to our radius, 200 feet, times our degree measure, that's this, in radian, which was pi over 2. If we throw this into our calculator really quick, we're going to get 200 times pi divided by 2 gives me 314.16, about 314.16 feet. Alright, and now if I use this formula to find the area of this sector, area is going to be equal to 1/2 times 200, that's our radius squared, times our degree measure in radian, which was just pi over 2 in this case. Alright, we put this whole thing into our calculator. We go 0.5 times 200 squared times pi divided by 2. Alright, big number. That's going to give us 31,415.93 feet squared, or square feet. These are our two answers. This is our length of the outfield fence, and this is the area of the sector.